exponential equations. Exponential equations, including some logs. First, we'll do them without logarithms, but then we'll do them with them. So first, let's say if I had 3 to the x equals 81. Well, I know that you know that that is 3 to what power is 81 is 4. But let's say you don't. Well, if you get them the same bases, like for instance 81 you can say is 3 to the 4th power. If the bases are the same and it's equals, you can just say x equals 4. Same thing if you had something like 2 to the x minus 5 power equals 16. Well, there's nothing you can do to the 2 and the x minus 5, but 16 is 2 to what power? 2 to the 4th. Same basis. X minus 5 equals 4. Add the 5. 9. They can even make you switch both of them. Let's say if I gave you something like 9 to the x plus 1 equals 27. Well, you know you can't write 27 as a power of 9, but you can write both of them as a power of 3, because 9 is 3 squared, 27 is 3 cubed, bases cancel, and don't forget to distribute the second term. 2x plus 2 equals 3. Subtract the 2 to get 1, divide by 2, 1/2. They can even try to get weird with you, and let's say 4 to the x minus 3 equals 1/8, where you're like, because 4 and 8 you can't write as a power of 4. And 4, 8, vice versa, but you can write them both as a power of 2. So 4, 2 squared, but then I know you're thinking, wait a minute, the 8's underneath. You know it's 2 cubed, but it's underneath. Remember to make it up top, negative exponent. So then, cancels, so 2x minus 6 equals negative 3. So add the 6 to get 3. 3 over 2. Now, all of those work if you can get the same bases. But let's say you can't. If you can't, like let's say 6 to the x power equals 20. As it is, you can't get that to the same power. You know, 6 to the first is 6. 6 squared is 36. So you know it's somewhere between 1 and 2, but to try to get that exact decimal or pretty close to it would be pretty difficult. Well, remember, here's where the logs come in. If, and just like with any equation, if you do it to one side, you got to do it to the other. If you take the log of both sides, and I know some of you are like, what did you just do? Well, hang with me. Remember, by the laws, exponents become coefficients. So you have x times the log of 6 equals the log of 20. If you want, you can do the calculator part now or later. You know, to find x, you just need to divide by log of 6. So then, handy dandy calculator. Where's my log button? I haven't used it very much on this one. I can't see the forest for the trees. Well, I'll do. Where is my... Oh, there it is. Sorry about that. Log of 20 divided by log of 6. 1.67. And sure enough, I typically round to hundredths. you knew it was between 1 and 2 and a smidgen closer to 2. So 1.67. Let's do another one. What about, let's say, 5 to the 2x minus 1 equals, I don't know, 82. Make one up, see how it goes. Well, first thing, you got to get this out of the exponent position. So log of both sides. So 2x minus 1 times the log of 5 equals log of 82. Same thing, if you wanted to, you could divide out first and get that decimal. Or you could, let's say, log of 5, about 0.6, might as well around 0.7. Log of 82, about 1.9. And now a little bit of algebra, 1.4x minus 0.7, 1.9. Add the 0.7, 2.6. Divide it out. 1.857, so we'll say 1.86. They can even make it where the variables are on both sides. If so, you would just distribute on both sides. You could even say, now some people, rather than take the log of both sides, some people prefer to take the natural log of both sides. But before we do that, I thought about one more. Let's say this one. I want to show you why. We'll say 75. Okay, this one, just like normal, log of both sides. But this one, you're going to see something nice happen. You get x plus 2 times the log of 10. And just so you know, I'm not making it up, log of 10 is 1. Now, the reason why is, remember, understood base 10. So 10 to what power equals 10? 1. So whenever you take, if you have a base of 10, you automatically, log is your best bet. And then log of 75, 1.9 or 1.8. I'll say 1.9. So then subtract the 2, negative 0.1. There you go. Now, what I was about to say. Let's say, I don't know, 5 to the 8x minus 7 equals 19. Now, one like this, you could take the log of both sides, but you could also take the natural log of both sides. Now, I know you're wondering, what's the difference? Well, the only difference is, since log is base 10 and natural log is base e, or 2.71, the decimals aren't as small, so sometimes they're a little bit easier to deal with. Because notice how natural log of 5, which before we did it, and it was log of 5 is about 0.7. Natural log of 5 is 1.6. So it's no biggie, but like I said, some people prefer natural log. You still are going to get the same answer once everything is said and done. Natural log of 19, 2.9. So 1.6 times 8, 12.8x minus 11.2, 2.9. Add the 11.2, so 14.1 divided by 12.8. And notice how I've been leaving the decimals off, because if there's 2 of them, they might as well not be there, and it just makes it quicker. X is 1.1. Now, you could have taken the log of both sides. You still would have ended up 1.1. Now, let's say one last one. If I gave you this. If I gave you something like this, since it's base E, you would have to take natural log. And so this comes out front just like normal, but something good happens because the natural log of e is 1 for the same reason that log 10 of 10 is 1. So when you take the natural log of both sides, that cancels. Then you just have natural log of 17, 2.83. So 4x equals negative 0.2. Divide by 4. So x equals negative 2 over 40 or 1/20. So negative 0.05. For all you naysayers, yep. There you go. So if it's just has a log base 10 or a 10, then I would take log of both sides. If it has an e for a base, you have to take natural log. Any other cases, log or natural log of both sides, whichever one you prefer. Hope this was of help to you. Have a great day.